My name is Javier Hernandez and my nickname is Chicharito.
What is up guys, this is Luke Hill for Kikuru, and while Z590 may have had a bit of a turbulent start to its life, it's still fresh and will be of interest to many users. So we're going to be taking a look at 3 ASUS ROG Z590 motherboards. First up, we've got the ROG Strix Z590i gaming Wi-Fi. So that's a pretty high-end, pretty premium mini ITX motherboard that comes in at about £320 in the UK. We're then going to be taking a look at the ASUS ROG Strix Z590e gaming Wi-Fi, and this is about £330–340 in the UK, and is kind of pushing towards the higher end of the mid-range pack. And then we'll also be taking a look at the enthusiast, pretty high-end indeed. This is the ASUS ROG Maximus 13 Hero. So this is about £460 in the UK, certainly expensive, looks to be premium indeed. But anyway, that's enough of the introduction. Let's take a closer look at these boards. Before we do that though, if you like what we do here at Kikuru, make sure you give us a like and subscribe, really helps us build the channel. Maybe we can get the next one of these. This is our 100,000 sub plaque, really impressed by that. Thank you for all your help there. You can also buy a cool t-shirt like this, check out the Kikuru website and watch the rest of the review, really helps us out. Let's get back into it. First up, we've got the ASUS ROG Strix Z590i gaming Wi-Fi. Of course, this is mini ITX. Nothing too in your face or too over the top for interference, except this double-decker M.2 heatsink, which could cause some headaches. We'll take a closer look at that shortly. In terms of connectors, we've got a single 8-pin for CPU power. We have 3 4-pin fan headers spread across the board, and these are all 12 watts or 1 amp, which is a bit meager from ASUS, especially if you're running splitters. Would have liked to see 3 amps at least there. Internal USB connectivity comes in the form of a Type-C USB 3.2 10 gigabits port, and also a 5 gigabits per second standard USB 3 port. And of course, everybody's favorite RGB. You've got 2 headers, one up top and then one on the daughterboard. ASUS is pretty smart with the allocations for space in terms of this mini ITX motherboard. They actually give you a couple of breakout cables to save some space, and this really does help. So we've got one for the front panel I/O and then one for dual USB 2 headers. And then in terms of expansion slots, we've got a single full-length steel reinforced slot, and this is PCIe Gen 4 by 16 if you're using an 11th gen CPU, or Gen 3 if you're using a 10th gen CPU. Of course, this is where your graphics card is primarily going to go, but it does support bifurcation of X8, X4, X4, or X8, X8 if you prefer. And that's pretty good if you want to run, for example, a high-speed mini storage server and rely upon the iGPU from the Intel chip. The daughterboard actually gives a top M.2 SSD and an underneath M.2 SSD in a double-decker design, and it's pretty smart in that respect. It's quite space-saving on an ITX platform. This is arguably a better approach than one SSD on the front and one SSD on the back, as we typically see from ITX motherboards. However, it does have a few caveats. For example, I was expecting the underneath M.2 SSD to be really easy to install, but I actually found it was easier to just whip off the VRM heatsink to pull out this daughterboard to get access to the underneath M.2 SSD, and that's really not ideal at all. One good benefit is, though, that ASUS provides thermal pads and metal cooling strips for both SSD slots. So unlike the backside SSDs that are common on ITX, you will be able to cool both drives here, so that's a big positive. The top slot is PCIe Gen 4 by 4 running directly from the CPU, so this will only be used with an 11th gen CPU, as is the limitation of the Z590 platform. And then the bottom slot is PCIe Gen 3 by 4 from the Z590 chipset, so this will always be usable, irrelevant of which 10th gen or 11th gen CPU you're using. Moving around to the rear I/O, it's actually quite big, but it should suffice. We get 6 Type A ports, only 2 of which are high speed, 4 are USB 2, one of which doubles as BIOS flashback, and this is just far too many slow legacy ports for a motherboard of this caliber on this platform. I have no idea what ASUS is thinking here. We also get a 20 gigabits per second USB 3.2 Gen 2 by 2 Type-C header, so that's good to see. And then the big dog, Thunderbolt 4 in Type-C form, of course, and that's from an Intel JHL8540, mouthful, Thunderbolt controller. Another area where ASUS also does well on the rear I/O is 2.5 gigabits Ethernet from an Intel i225V controller, and then you also get high-speed Wi-Fi 6E, and that's from an Intel AX210 controller. So that's really good to see if you want high-speed networking, especially the Wi-Fi, which is going to be particularly important for a mini ITX platform going forward. I guess I should pause at this point and say if you're ever dealing with a motherboard, then be careful, because I've just pranged myself on one of the sticking out pins, and I seem to have cut my finger. So I'm going to take a quick pause, I'll be back in a second. Okay, finger somewhat tidied up. Let's continue our look at the rear I/O. So you've got full-sized HDMI 2.0, and then you also get DisplayPort 1.4 through the Thunderbolt 4 header, so that's good to see. Dual 4K 60 video outputs if you want that for the iGPU. And then disappointing areas for the rear I/O are a lack of clear CMOS, which would have been good to see, but it's not here. And then you get quite a limited selection of audio outputs, which is disappointing given the high-end chipset used. If we now focus on the VRM, ASUS deploys a really well-built, solid heatsink design for this ITX motherboard. The metal construction is dense and reasonably heavy, and the screw-down installation is high pressure and makes good contact between the thermal pads and the VRM components. And you also get a heat pipe connecting both individual metal cooling blocks. Housed on the left side heatsink cum rear I/O cover is a 30mm VRM fan. This has its own dedicated speed control header and pushes air through a small set of metal fins. And grills above the fan on the rear I/O cover allow for airflow access. The power delivery solution itself is designed with 11 stages split as 8 plus 2 plus 1. You get a high quality Intersil ISL 69269 PWM controller to manage the system without doublers, and then the MOSFETs are Texas Instruments 95410 power stages, and these are used for the CPU V-core, and they look to be rated at 90 amps current output. So you get a theoretical 720 amps peak output for the 8 stages driving the CPU, which looks to be perfectly adequate in general, especially for an ITX motherboard. And then the 3 remaining power stages are lower rated Texas Instruments 59880 70 amp stages, which are still very high end, especially for the SoC. So I think that covers our brief overview of the Z590i gaming Wi-Fi. Let's put this one back and move on to the next board. Next up, we've got the ROG Strix Z590e gaming Wi-Fi. And in terms of styling, this is again largely black and dark grey in terms of appearance. We do get this pink line. I'm not sure if that's meant to be pink or red, but it's certainly pink to my eyes. Bit weird, but whatever. And then we've got this holographic ROG Strix logo. And then obviously one of the improvements here is that we've got good subtle RGB lighting on board in a few different locations, and this is manageable by Aura. Focusing on the connectors, you've got 8 plus 4 pin for CPU power. That's going to be fine for a board of this caliber. You have 8 total 4-pin fan headers, and the distribution on this motherboard is absolutely fantastic. The only issue I have is that 7 of them are 12 watts 1 amp rated, and only one of them is 3 amp 36 watts. I particularly like the distribution of the AIO pump header right next to the CPU socket. That's really good because you don't have to trail a cable up the top of the board. Internally, we've got obviously the usual 5 gigabits per second USB 3 case header, and then now we're upgraded to a Type-C internal header. However, this is USB 3.2 Gen 2x2, 20 gigabits per second. So this is really good to see. And then another inclusion that I like is the onboard 2-digit debug LED and the post LEDs. In terms of expansion slots, we get 2 full-length steel reinforced slots, and these are driven by CPU lanes, so they will be Gen 4 if you're using an 11th gen CPU, Gen 3 if you're using a 10th gen CPU. You do technically get SLI support because they can run at X16, X0 or X8, X8 plus bifurcation modes, but I mean SLI, not even Jensen cares about that anymore. Who cares? And then the bottom full-length slot is PCIe Gen 3 by 4 using lanes from the chipset. However, it does share some bandwidth with SATA ports, so watch out for that. Storage-wise, we have 4 M.2 slots in total. The top one is PCIe Gen 4 by 4. And that's obviously running from the Intel 11th gen CPU. If you're not using an 11th gen CPU, that slot is dark and unusable. Again, a Z590 platform issue more than anything else. The secondary slot is actually running from a Gen 4 CPU or a Gen 3 CPU lanes, and it does this by stealing bandwidth from the second full-length PCIe slot. So if you've got a 10th gen or 11th gen, that will drop the top slot from X16 down to X8, and it will limit the second slot to X4. So in other words, this is a good high-speed port with a direct link to the CPU. However, it should probably be used as a last resort, or if you're happy to run your GPU at by 8. And then the other 2 slots are PCIe Gen 3 by 4 from the chipset, and one of them also supports SATA by stealing a port from one of the physical SATA ports. And good job, you've got 6 of those on board, plenty of spare there. I'd say overall bandwidth allocation for the M.2 slots is very good, because with an 11th gen CPU, for example, you can run all 4 M.2 slots with high-speed SSDs, whether they're Gen 4 or Gen 3. and you don't really get too much bandwidth penalty there other than running your graphics card at by8, which is probably fine if you're not using the fastest of the fast graphics cards. ASUS heatsinks are also solid, even if the top one was a bit annoying with that RGB cable stuck to it. The bottom one and the middle one are very, very good. And not only the heatsinks are very good, the ASUS toolless installation method for the SSDs is fantastic. This is a small and subtle piece of innovation that I really appreciate. You don't have to mess around with the annoying, frustrating M.2 screws, which are tiny and just awkward and always fall somewhere you don't want them to fall. Plastic, toolless rotation clip, very smart indeed. I want to see this more going forward because this is a fantastic design. Good job there, ASUS. The rear I/O is what I would call superb for this caliber of motherboard. We've got 8 Type A ports, 6 of which are high speed, and I'm perfectly happy with having 2 old USB 2 ports, obviously one of which is BIOS flashback. You've then got a 10 gigabits per second Type C and also a 20 gigabits per second Type C, so USB 3.2 Gen 2 by 2, great if you have a fast SSD. No Thunderbolt 4, but that's probably fine for a board of this target audience and caliber, in my opinion. Overall though, the USB configuration on the rear I/O is superb. Networking connectivity is also very good. You get a pair of Intel 2.5 gigabit i225V Ethernet controllers, and you also get Intel AX210 Wi-Fi 6E if you've got a fast new router. And then one other point that I really like is the inclusion of a rear clear CMOS button alongside the BIOS flashback button. For the VRM, ASUS deploys a massive multi-tiered metal heatsink. So you basically got 2 solid blocks of metal, one of which integrates as the rear I/O cover, and they are connected with each other via heat pipe. This design is absolutely fine in my opinion because there's so much surface area and mass of metal that you're not really going to have cooling headaches. I don't think you'd need a fan here. However, ASUS does for some reason include a bracket where you can install a fan, and they actually do give you a small 40mm fan in the package, and you've got a dedicated VRM heatsink header at the top. Personally, I didn't use this in testing, and I would not use this. I don't see the point in it, especially with the efficient power delivery solution beneath that we will see. But I guess this inclusion is good if for whatever reason you need the fan. Whatever, I just wouldn't use it. The power delivery solution itself is a 17-stage design, and that's 14 plus 2 plus 1 for the split. A high-quality Intersil ISL 69269 PWM controller manages the system without doublers. 14 70-amp rated Texas Instruments 59880 power stages are used for the CPU V-core in a teamed configuration. This gives a peak theoretical 980 amps current output for the CPU V-core. 9 CPU V-core stages are to the left and 5 are to the top, and this makes perfect sense given the mass distribution of the VRM heatsink. Rounding out the VRM are 5K rated mil capacitors, and overall I would say this is a very premium VRM and power delivery solution for a motherboard of this caliber. There's not really much more you could do at this price point, so good job there. I think that covers most of the main features for the ROG Strix Z590e gaming Wi-Fi, so let's move on to the hero. Sitting a rung above the Z590e gaming Wi-Fi in ASUS's product stack, the Maximus 13 Hero basically takes a lot of the Z590e gaming Wi-Fi features and just adds to them for enthusiasts and overclockers in particular. Notably, the power connectors have been upgraded to dual 8-pin, and this is probably targeting more enthusiast overclockers with higher cooling solutions. You still get the same 8 4-pin fan headers. You also get greater focus put on liquid cooling, for example, with some water in, out, and flow detection headers. That's good to see. In terms of connectivity, you still get the 20 gigabits per second Type C internal port for the header. Very smart there. And you also get 2 USB 3 headers instead of the 1 for the lower end board. Alongside the 2-digit debug LED and the post LEDs are the start button, the flex key, which is reset by default, and then you also get a retry button down the bottom. In terms of expansion slots, the layout and the configuration is basically the same as the Z590e gaming Wi-Fi. This time, however, the bottom full-length PCIe Gen 3 x 4 slot actually shares bandwidth with 4 SATA ports rather than 2, according to the manual, so watch out for that. You still get the 4 total M.2 slots, and the configuration is primarily the same. One important change, however, is that M.2 slot 4 now shares bandwidth with 2 SATA ports. That means that an SSD in M.2 slot 4 and an X4 expansion card in the lower PCIe slot will leave you with none of the 6 SATA ports usable. The M.2 heatsinks have also been beefed up slightly, so you can see the top one is a stacked multi-tier approach with a big bulky piece of metal there, and then the middle one does branch out to this cover for the chipset, which is a bit annoying for initial installation, but it does add some mass to the actual cooling system, so that is a positive. One notable downgrade here versus the Z590e gaming Wi-Fi is that you don't get the toolless turning clips for M.2 installation. The rear I/O of the Hero is absolutely fantastic and once again offers a slight, or well, actually quite a big upgrade over the Z590e gaming Wi-Fi. You get 8 total USB Type-A ports and 6 of those are 10 gigabits per second, which is great to see. Obviously the 2 USB 2 for keyboard and mouse, and one of which doubles as BIOS flashback. Catering once again for enthusiasts with deep pockets. The Hero offers 2 Thunderbolt 4 ports in Type-C form, which is excellent to see. And if you've got high-speed storage devices or you're a productivity user or a video editor, you're probably going to like these a lot. And of course they run from the same Intel JHL8540 controller that we saw on the ITX board. The rear clear CMOS button is also upgraded, and that's just a good quality touch. Minor, but quality. The VRM heatsink is absolutely gargantuan and is actually even bigger than the Z590e gaming Wi-Fi, which in itself was already massive. Clearly, it's basically 2 blocks of metal. The 2 individual blocks are multi-tiered with some degree of thinning and surface area enhancement, and then this doubles up to the rear I/O cover on the left side, so you get a massive bulk of metal, which is genuinely really heavy, makes the board really pretty heavy indeed. And solid, because you negate the twist with that stiffened in place, but also you got a lot of surface area, so you're going to dissipate a lot of heat through here, and ASUS is clearly confident in the design because there's no fan and there's no ability to install a fan like with the lower end boards. So as far as cooling goes, I got quite a bit of confidence here already. The power delivery components also get an upgrade on the Hero. We still get 17 total stages, split as 14 plus 2 plus 1. But now the 14 teamed stages for the CPU vCore, run by the Intel ISL 69269 PWM controller, are 90 amp Texas Instruments 95410 power stages. That basically means that this board is going to be good for extreme overclocking if you want to put LN2 or something ridiculous on there, or realistically, even if you're doing pretty aggressive liquid cooling in daily operation, you're just really not going to stress this VRM particularly hard. It is a monster. And then the 3 non-CPU vCore power stages are again the same Texas Instruments 70 amp stages that we've seen on some of the other boards. Overall, I would say this is a particularly high-end power delivery solution that really is pushing towards hardened enthusiast territory. Those 14 90 amp stages are just ludicrous. You're not going to have to worry, and clearly with this large slab of metal cooling the board, no concerns at all, but we'll see in our testing. I think that'll do for the brief overview of the 3 motherboards that we're looking at today. We will be testing all of these boards on our usual test system. We put the data in the charts. However, we're going to put particular focus on the ROG Strix Z590e gaming Wi-Fi throughout the review. We're going to do a bit of additional testing on this with adaptive boost and the likes and looking in the UEFI. And that's just because we think that this board is a bit more appealing and a bit more realistic for what people will generally buy. Obviously the Hero is very high-end and ITX is still pretty niche, so we're going to go with this one. Overall, I continue to like ASUS's ROG UEFI. The settings are clear, the layout is good, and the overall experience is positive. It's stable, it works well, and I even like the little graphics to show you that fans are spinning. A really proficient, easy to use UEFI. Our Z590 test system is built around the Intel Core i9-11900K Rocket Lake 8-core processor, and we pair this with 32 gigs of Corsair Vengeance LPX DDR4 memory run at 3600 MHz C16 with XMP. The Core i9 processor in particular gives us a good opportunity to test the power delivery solutions on these motherboards, even if we didn't really get all that positive of a recommendation towards it in our review. It is certainly a power-hungry beast when you push it. Great for motherboard testing. Clean power comes from a Panasonic TX1000 titanium-rated 1kW PSU, and we use a WD Black NVMe SSD for storage. Cooling is nominally a 280mm Asetek 6th Gen AIO, and that's on our open-air test bench that we use for all of the testing usually, alongside the Gigabyte RTX 3080 Eagle OC graphics card. But when we up the ante for adaptive boost testing on the Z590e gaming Wi-Fi, we up the ante with cooling and we put it inside our EKWB liquid cooled solution with custom liquid cooling from a 360mm rad. In doing so, we actually had to switch out the graphics card because the 3080 doesn't fit inside there. So for this, we used the RTX 2080 Ti Aorus Extreme, but we were just running CPU tests, not gaming tests, just to see how adaptive boost would perform. If you want more details on the test system and the procedures and all the settings and stuff like that, either ask in the comment section down below, or first and foremost, check out the Kickguru website. Let's start by looking how the Z590 board performs. Got HWinfo and Task Manager and CPU-Z running, so let's just load up Cinebench and see how the system performs just out of the box, stock XMP with multi-core enhancement from ASUS enabled. And then we can see straight away we're at 4.8 GHz on the CPU, so 4.8 GHz all-core. Temperature with our custom liquid cool setup is really good because we know these chips do shed their heat a bit better than previous, so than the 9th gen for example. And there we go, initial run is complete. Ignore this score because we've done more accurate benchmark testing, but we can see the temperatures reached about 66 degrees Celsius on proper liquid cooling, so this is a really high-end cooling setup. And the VRM was nice and easy, no stress there, but obviously this is a short run. That power though, sub 200 watt, just under 200 watts for the package, that's really, really high, even for 4.8 GHz on 8 cores. Now we can have a look at the behavior using Intel's Core i9 11900K with the adaptive boost setting applied by the Z590e gaming Wi-Fi motherboard. We've just cleared the CMOS, let's jump into the UEFI, obviously hitting F1. What we're going to do now is apply XMP version 1. So if we go XMP version 1, this, according to the information, applies some of the ASUS tweaking, but primarily the XMP. And now we're going to enable adaptive boost, and let's see if this works for adaptive boost. We're booted up and into Windows, let's load Task Manager and HWinfo, and then let's see what the performance of adaptive boost is here. So like I said, this is XMP version 1 in the ASUS UEFI and Intel adaptive boost enabled. Let's load it up. And what we can see again is this is locked at 4.8 GHz, 4.8 GHz, but 183 watts, 184 watts of package power. So once again, with XMP enabled, this is not working for adaptive boost. So this looks to be a bug in the ASUS UEFI. Let's try and fix that. So that was a bit of a disaster. Somehow ASUS has managed to basically disable the only worthwhile feature on the 11900K when we're using XMP. Let's have a look if we can fix that mess, because right now adaptive boost is not working. We've cleared the CMOS again. Let's jump back into the UEFI. And this time, rather than enable XMP, because we've already shown that that just doesn't work with adaptive boost, and we have tried the different multi-core enhancement modes, they also do not work. So instead, what we're going to do is go auto, we're going to enable adaptive boost from the start, and then we're going to manually tune our memory. For the DRAM voltage, we're going to go 1.35 as that works for our kit. And then we're also going to have to change the DRAM frequency to DDR4 3600. So you can see already this is a more involved process, and I haven't even tweaked the cache. So that's likely to be slightly different, perhaps better, perhaps worse compared to our XMP profile. But let's now run this with the memory manually at 3600 C16 and with adaptive boost enabled. Let's see if this works. After our manual tuning in the BIOS for the RAM at 3600, let's just launch up Task Manager and we'll load up HWinfo 64. So we can see that the memories run at 3600 and we've got 18, 18, 36. So not optimal timings, obviously, because it's not XMP. But let's have a look and see if adaptive boost actually runs now that we haven't used XMP but have manually tuned our RAM. And there we go. 5.1 gigahertz, and you can probably hear, wow, these are loud fans. We're using the liquid cooled test system, ramped up very, very heavily. 5.1 gigahertz, my word, 250 plus watts, and this is going to increase if we run it for longer. But that, as far as I'm concerned, is adaptive boost working. There we have it then. I guess we can disable XMP, manually tune the memory with our kit at least, and then adaptive boost will work on this motherboard. If you run into an issue like this, then make sure you watch out for XMP. It could be causing some headaches. We have relayed the problem to ASUS, so hopefully a BIOS update will be able to fix this, as we're using Corsair Vengeance memory, which is basically a mainstream go-to option these days, in my opinion. Anyway, let's have a look at some of the performance numbers, shall we? Looking at CPU-focused performance in Blender, we see ASUS's options scoring very closely to Gigabyte's Z590 competitor that Leo tested. This is because the Core i9 11900K was running at the same nominal 4.7 to 4.8 GHz clock speed. Applying adaptive boost increases performance beyond that of Gigabyte's competitor. Cinebench R15 numbers from the ASUS boards are better than Gigabyte from the start. The score is basically even when adaptive boost is applied on the Z590e gaming Wi-Fi though. We see the same trend in Cinebench R23, whereby ASUS's Z590 options score a little higher than the Gigabyte board that Leo tested when it's stock. Adaptive boost delivers a healthy performance gain for additional heat and power. Performance between all of the boards is very close in 3D Mark TimesBy, so we have no initial reasons to be concerned with gaming performance. The Z590e gaming Wi-Fi did consistently score a minor victory in F1 2020, but this is realistically irrelevant, especially at 200 plus FPS. And the extra couple of FPS from the Z590e gaming in Shadow of the Tomb Raider is measurable, but again, realistically irrelevant. Looking at power draw when running 30 minutes of Cinebench R23 NT on loop, we see some interesting results. The Hero looks to have the most efficient power delivery system, albeit by a very minor margin. Realistically, we would say the Z590e is equally efficient despite using a slightly lesser performance set of VRM components. The ITX Z590i gaming cannot keep pace with the 14-stage vCore setups from the ATX boards. This represents a slightly higher CPU package power draw and system consumption at the wall, despite offering the same performance as the ATX boards. Applying adaptive boost sees the power consumption numbers skyrocket on the Z590e gaming Wi-Fi, 5.1 GHz, monumental power draw up at kind of 275 watts. Temperatures are fine because we often see that with good cooling, these new Intel chips, or 10th gen onwards, do react quite nicely to even a lot of power. They do cool okay if you have good cooling, but this, as far as I'm concerned, is adaptive boost running very healthily, depending on your perspective, of 275 plus watts. We've got about 410 watts of power draw from the wall. The package power spirals up to 277 watts, and the wall power increases by more than 140 watts to 417 watts. All that for an extra 300 to 400 MHz doesn't seem worth it from an efficiency and cooling standpoint. VRM cooling performance is excellent on both the Maximus 13 Hero and the Z590e gaming Wi-Fi. This is unsurprising given their similarly oversized heatsink designs and 14 power stages for the CPU vCore. Impressively, the Z590e gaming Wi-Fi maintains a sub 70°C VRM temperature even when shifting 277 watts of power to the Core i9 11900K with adaptive boost enabled. This is a very strong result and had us thoroughly impressed even if it was whilst installed inside a chassis with custom liquid cooling on the CPU. The Z590i ITX board struggles a little more with managing the power requirements of the 11900K. 69°C is certainly a reasonable result for a CPU load of almost 190 watts. However, the 30mm VRM fan was spinning around the 2000 RPM level to achieve this result. Thankfully, the VRM fan was completely inaudible over our 280mm all-in-one liquid cooler at full load. That's enough testing, let's round this one out. So I guess I'm going to start by saying the adaptive boost / XMP bug that we saw from the UEFI of ASUS with our Corsair Vengeance LPX DDR4 memory and the 11900K is annoying. It shouldn't be on boards of this caliber, but we have relayed the error and we're quite confident that this bug can be ironed out with a BIOS fix, so just stay tuned for that, I guess. If we focus first on the ROG Strix Z590i gaming Wi-Fi, the ITX version, overall this is a board with a high quality power delivery solution that did a good job for the cooling of that system and performed well throughout our testing. It's a smart overall design with very few minor complaints, quite frankly. The M.2 Daughterboard is good in theory. It's a little bit fiddly in practice, especially installing that underside M.2 SSD, but it does save space on the board so you can get more components in there, so we have to give ASUS credit there. I was not impressed by the rear I/O. 4 legacy USB 2 ports on the backside is just ludicrous in today's market when you don't have enough 5 gigabits per second or 10 gigabits per second nearby. ASUS needs to go back to the drawing board there and fix that because this is pretty ridiculous, quite frankly. But 20 gigabits USB-C is certainly one of the areas where the board does make up for that annoyance on the USB Type-A ports, and the fact that Thunderbolt 4 is included is a real strong positive for the mini ITX ecosystem. So basically, very expensive at £320 in the UK, and perhaps difficult to justify given the platform that this is on and just the sheer cost of the motherboard, especially when AMD is pretty competitive these days with ITX, aside from Thunderbolt 4. A good quality board overall, but it's a little bit difficult to get excited about a high-end premium Z590 ITX board when number one, there's tough competition from the MSI Unify in particular at a lower price point. Plus, the Intel ecosystem doesn't seem to be really well tuned for ITX at the moment, especially for the high-end, power-hungry processors. The Maximus 13 Hero, this is overkill in so many respects. The power delivery solution is ludicrously high-end and really does deserve credit. Even if you're a hardened overclocker, you're going to be perfectly satisfied by this, especially with the big block of metal cooling, so smart design there. And then it's good to see greater emphasis on tweaking features such as onboard power buttons, some water cooling stuff, and just an overall kind of more enthusiast, more overclocking geared design. At £460 though, this is a really tough swallow. This is going to be your enthusiast, hardened overclocker, liquid cooler motherboard for those types of users, or somebody who just wants a really premium motherboard and doesn't really care too much about the cost. $460 is ludicrously expensive, but actually I think ASUS has kind of carved out a bit of a niche here given the competition, which is stiff from MSI and Gigabyte, but the Hero holds its own very well. I guess one of the few complaints I have is, at this price point, I would have liked to see at least 5 gigabit or probably 10 gigabit networking rather than 2.5 gigabits. But that's probably one of the very few downsides. Good board, very expensive. And now if we focus on the ROG Strix Z590e gaming Wi-Fi, this is the board in particular that I really did like from this roundup. It's high-end, it's premium, but it's also just very sensible in its hardware choice and its overall design. I think the downgraded power delivery solution and the lack of some overclocking features versus the Hero is basically a non-issue to most users, and the omission of Thunderbolt 4 is probably not going to worry too many non-productivity users either. The bigger positive from those exclusions is the £120 price drop that we see versus the Hero. So this board comes in about £330, £340 in the UK, which is certainly still very expensive, even for Z590, but is far more tolerable. With that said, there are a couple of cheaper ROG Strix motherboards that offer the same core feature set to the Z590e. So you've got the A and the F, for example. And that's without even looking at competitors from the likes of MSI and Gigabyte, who do have options in this price point and slightly cheaper that are very comparable. But if you have reason to go for a high-end Z590 Rocket Lake build, I feel like the ROG Strix Z590e gaming Wi-Fi is a good solution overall, especially if you can use the subtle upgrades to the networking and the RGB versus some of its lower-priced ROG Strix brothers. Pretty good option overall. I do quite like this board. I've been Luke Hill for Kickaroo. Thank you for watching this video review of 3 ASUS ROG motherboards. Let us know what you think. Is Z590 a platform that you're just purely not interested in, or are you actually quite impressed by some of the innovations that the motherboard manufacturers have been bringing to this platform? Let us know in the comment section down below. If you like the video, give us a like, help us subscribe and get this next plaque by clicking that subscribe and the bell icon. That really helps us out. And if you want to see more like this, then check back always. Check the Kickaroo website for the written review. Buy a cool t-shirt like this, interact with us on Discord, and catch you in the next one.